Okay, so now we're getting a little bit more involved here about solving a quadratic equation. This one needs some simplification. If we take a look at what we've got right here, that doesn't look like anything. Well, it looks a little bit like what we were familiar with the quadratic, but we've also got this w plus 1 quantity squared on the left-hand side. So remember, our goal is to always get it so that it looks like ax squared plus bx plus some constant c all equal to 0. So we want one side of that equal sign equal to 0. And then we only want 3 terms on the other side. So let's go ahead and multiply out this side right here, the w plus 1 quantity squared. So if I do that, let's see, whoops, I have w plus 1 quantity squared. If I just take a look at that, that side multiplies out to be w squared plus 2w plus 1. Okay? If you remember, and I'll write it down here, that's the same as w plus 1 times w plus 1, right? So you want to go ahead and multiply all of that out, and you'll see that you get this part right here. And you should be familiar with that. So all of that now equals 2w squared plus 9w plus 11. And remember, I want to make everything 0. And I notice that I have a couple of terms that are similar on both sides, right? I have a w squared term here and a 2w squared term. So I'm going to try to keep my coefficient of my w squared term positive. So I'm going to go ahead and subtract w squared from both sides. And then I'm also going to subtract this 2w from both sides. Well, let me first go ahead and do this. So I've subtract w squared from both sides, and I'm left with 2w plus 1 equals 2w minus 1w is just w squared, or 2w squared minus 1w squared is just w squared, plus 9w plus 11. And now I'm going to go ahead and subtract the 2w from both sides. Those are my like terms. So I'm left with 1 equals w squared plus 7w plus 11. Oops, not a very good 11, but plus 11. And then my last one is I'm going to subtract 1 from both sides. So I can rewrite this entire problem now. Let's go back up here. After expanding out and combining like terms, I can go ahead and rewrite the whole thing as I have w squared plus 7w, and 11 minus 1 is plus 10, and all that, this part here goes to 0, so all of that equals 0. So now that is my new quadratic. And now this is so straightforward, right? You're very familiar with our leading coefficient is 1, so we know that we can go straight into the double bubble, right? And that's going to equal 0. So we're looking for factors of 10 that add up to 7, right? So 2 and 5 come immediately to mind. So now I know I have w's in both of them, and I have 2 and 5, and they're both positive, so I have a plus 2 plus 5. Again, this has to equal 0, w plus 2 has to equal 0, or w plus 5 has to equal 0. So, in the first case, when w plus 2 equals 0, that implies that my w equals a negative 2. And in the second case, I have w plus 5 equals 0, and that's going to solve out to be w equals negative 5. So my two answers are w equals negative 2 and negative 5. Whoops, not very nice again, but we'll write it down. So w equals negative 2, or negative 5. And that's my answer. So if I plugged W equals 2, W equals negative 2, or if I put in W equals negative 5, I'm going to make this true.